So now we have an explicit definition that we're trying to write recursively. So the key things to pick out are the two things we care about, which are the common difference, which in this case is 7, and the first term, right? The first term, right? So if we think about the formula we talked about in part A, the first term is 1, the common difference is 7. So if we think about the structure of the recursive definition in part A, part B's recursive definition will have the same structure. We'll have something to talk about the first part, and then something to talk about what happens to the previous term to get the next term, right? Because that's how recursive definitions are going to operate. So in this case, we're going to have a sub n is going to equal 1 when n equals 1, right? Because 1 is the first term. And then what happens to the previous term to get the next term? I have to, excuse me, I had to sneeze. Okay, so what's happening each time? If 7 is the common difference, and arithmetic sequences add the same thing each time, then we're just taking the previous term, which we represent with a sub n minus 1, and we just add 7 each time. And that's for all values of n greater than 1. All right? So we can use the same sort of structure of the previous recursive rule to think about their structure for any recursive rule. Right? Any recursive rule, we care about what happens at the start of the sequence and what happens to the previous term. Okay? And just like in the previous problem, we care mostly about the first term and the common difference, and that'll help us represent this in either mode, whether it's recursive or explicit. Okay?